This is the question. At a certain university, 52% of all students pass. 48% of the male students pass, and 55% of the female students pass. Now, this is very realistic. We also find at university that more female students pass than male students. I'm not sure exactly what the reason is. Maybe the male students are duller, but also maybe the male students are not as dedicated to study as female students. If the ratio of the number of male students who pass to the number of female students who pass is expressed as a fraction small m over small f in lowest terms, determine m plus f. So this is quite a mouthful here. We are saying at a certain university, 52% of all students pass. Now, we have to give some symbols here. We don't know how many people are passing. So we have to start with some symbols. Let's see. The question is, if the ratio of the number of male students who pass, okay, let's give a name to that. The number of male students who pass, let's call it capital M. I don't want to confuse it with the small m here, which is in lowest terms. So capital M equal to the number of passing male students. And likewise, we'll let capital F be equal to the number of passing female students. Right? So let's just see what the question is. The ratio of the number of male students to pass, if you have the ratio of m over f in simplest terms, so you know this might not be the simple term. You might have something cancelling off. When you rewrite it by taking out the highest common factor, when you rewrite it like this, okay, you have to rewrite it like this and then calculate m plus f, and that is what the question is. So we need to calculate m over f, simplified, and then we can get the answer. Okay, now so we know that m represents the number of passing male students and f number of passing female students. Now let's go and look at the information that we have. At a certain university, 52% of all students pass. So you either have male students or female students. All right, so let's just have a look at this thing. You got 48% of the male students pass. So maybe we shouldn't put passing male students. We should write down the number of male students. Not the passing male students. Because the information is 48% of all male students pass. So to use this information, let's just take this thing out for the moment. Okay, so 48% of all male students pass. So what does this mean? It means, just one moment, I just want to check to see what I did, to see whether, oh, I've got 4 symbols here. All right, sorry, I'll have to redo this thing. Okay, I'm sorry about this. Let me just go back to this, erase this thing. And let me go to my whiteboard. Let me go to my whiteboard. and do everything there so that we can see what we are doing. And I'll repeat the information because you cannot see the information anymore. So let's just push this up a little bit. And we give names now. All right, so now I looked at my own solution and I noticed that I put A equal to the number of male students in the school. Males in school or at university altogether. Little b is the number of females altogether at the university. And now we have, I can use my capital M, is the number of passing male students. And capital F, the number of passing female students. Okay, right. Now we've got all the symbols in place. The information says that 52% of all students pass. All right. So you got A and B is the total number of males. So altogether, you have number of students in the university altogether. I can't write anymore because we're so used to typing. It's A plus B. That's the total number of students. And 52% of these pass. So 52 over 100 of A plus B actually pass altogether. Right. So just hold on with that. They say that 48% of the male students passed. So the male students is this. So 48% of the total number of male students pass. And we said we got the symbol here for the number of passing male students, capital M. So this is the number of male students who pass. And we also said that 55% of the female students pass. So the number of female students altogether is B. And we said the number of passing female students, we use that as your symbol. Okay. Now, in other words, altogether, the number of people who passed was passing males plus passing females. So 48 over 100. Let me, I'm not going to take up too much of space. I need more space to write. Okay. So if you count the total number of passing male students, you can count them in two different ways. We've already said that this is the number who passed, and we can add these two to again get this number who passed, which means that when you add these, this is the number who passed in one instance, and in the other instance, that's so they must be equal. This is the total number of students who passed. These are all passing students. Okay, now you got an equation. So if you can multiply right throughout by 100, you'll get your 48A plus 55B equals 52A. Let me expand the top there. It's 52A plus 52B. Okay, so we have, we can bring all the A's to one side. I've got 52A here, 48 here. So let me bring the 4A to this side. And you got 55B and 52B. Take the 52 that side, and you have 3B. So you have a nice little ratio of the number of males altogether. So A is to be number of males to females in the school. Okay. Okay, so 4 times the males gives you 3 times the female students. All right. So where do we go from here? We have used all the information that we have. And how do we now find, the question is, how do you find the ratio of male students who pass to the number of female students who pass? In other words, we are trying to get to this. What is that equal to? Okay, I want to go back to this equation here. M is equal to 48 A over 100. Let's simplify that. 4 goes into this, into the top. 4 goes into the bottom as well. I just want to preserve this equation. And here too, I can simplify this to get 11B over 20, because 5 goes into the top, 5 goes into the bottom. Now, look at these things which are boxed here. Something which you might not notice, and this is, an important fact in number theory. Remember, A and B and M are all natural numbers. They all are numbers like 1, 2, 3, 4, and so on. They're not fractions. Now you got 12 times A divided by 25 is a whole number. So this thing here gives you a very important piece of information, because A can't be any number. When you multiply 12 by A and divide by 25, you get a whole number, because M is the number of passing males. So what's the conclusion from this? This is a fraction, and it's going to be a whole number. 12, there's no common factors here. So this means that 25 will go entirely into A. I'll repeat that. 12 and 25 have no common factors, and this thing is a whole number. So when you simplify this, 25 goes entirely into A. All right, somebody is asking me a question. Okay, if you got any questions, as we said last week, we can raise it towards the end, unless it's something which you really need to tell me. Maybe you can't hear me, or you can't see it, or something like that. So from here now, we get the information that A is a multiple of 25. See? And if you look at this, again, we have that B is equal to 4A over 3. And we'll use the same argument here. B is also a whole number. And 4A over 3, 3 and 4 don't have any common factors. So A will have to be a multiple of 3 as well, and of 3. So A is going to be a multiple of A, and it's also going to be a multiple of 3. So therefore A is a multiple of 25 and 3. So it goes to show that A must be the least common multiple of 25 and 3. It's a multiple of both, is 75. Right? But there are several other possibilities for A, because there are other numbers which are multiples of 25 and 3. So A could be 75 or 150, or any multiple of 75. Okay, now let's just use the same argument for B and see what happens. If you look at this, this says that B is a multiple of 20. Again, 11 and 20 don't have any common factors. So B is a multiple of 20. And from here, if you write A, you can write A is 3B over 4. You will see that B is a multiple of 4 as well. So B is a multiple of 4 from this equation, because this is a whole number, and this fraction is a whole number, and it's you can cancel. So it means 4 goes exactly into B. So, which is a very important fact. It means that B is a multiple of 4. B is a multiple of 20. So, okay. So it means that B is a multiple of 20 because 20 is already a multiple of 4. So as far as B is concerned, B is going to be 20 or 40 or something like that. It's a multiple of 20. Right. Now, once you have that, now we have an idea of what capital M is, right? Because we've got values for M. We know possible values for A. So what are the possible values for M? It's 12 times A divided by 25. So 12 times A divided by 25. Divide this by 25 and multiply by 12. If you divide this by 25, you have 3 times 12 is 36. And again, 12 times A. Okay, these are all, so you get 36, 72, and so on. They're all multiples starting from 36. And likewise, you go back to F. B is 20. So the F value will be 11. So B is 20. Okay, it could be 11. 22, and so on. Okay, so we need to work out M over F. I messed up here somewhere because these, I don't recall this as being a possible thing. Let me just see. Oh, I see. You see, A, we have to substitute the possible values for A here. Sorry about this. We needn't have gone to that. Let me just go back. My apologies. We got all the possible values for A, right? There's B. So you use this to work out what the possible values of B are. So that would have been the correct thing to do because we know what the possible values of A are. So B will be, you have to take A divided by 3 and then multiply by 4. So when you divide this by 3, you get 25, and you multiply by 4, you get 100. And after that, it's all the multiples of 100. So once we got these, then we can put M. Right, to get M now, you have to take A divided by 25 and multiply by 12. And you divide this by 25. Now that is how you get 36 and all the multiples of that. And B, capital F, you divide it by, what did we say? Oh no, we know what B is. It's 100. So you put 100 here, so you divide it by 20 and multiply by 11. So when you divide 100 by 20, you get 5. You multiply by 11 and you get 55 and all the multiples of 55. Okay, so we need to work out M over F. You'll see the possible values are 36 over 55 or 72 over 110. There are lots of possibilities, right? And so on. But we are looking for the small m and the small f, which is in lowest terms. So these In the other ones, you can cancel. You see, you can cancel the 2's here, or if you take the 3 times, you can cancel the 3's. So those are not in lowest terms. This is the only one which is in lowest terms. So the small f, m, must be 36, and the small f must be 55. If you remember, we said m over f is in lowest terms. So this has to be the fraction you are taking. And the question was, what is m plus f? So it's 36 plus 55, which is 91. It's a hard problem, guys. It's a hard problem. So it's a good example to illustrate how numbers work. So when you got a fraction like this, remember, you got 12 times a over 25. This 25 and this have no common factors, and you can simplify this to get a whole number, which means the 25 must have gone exactly into a. That's a very important fact about fractions. See, 25 would have gone exactly into a because nothing here cancels. So that is what we used. So a is a multiple of 25. See, and that is a very powerful fact here. And it's also a multiple of 3. And that told us what are the possible values for a. In number theory, very often you have this kind of a thing where you have several possibilities. And that is why they say, what is the least? They limit it down so that you can get only one answer. But usually, if you've got multiples like this, you've got quite a few possibilities, right? And you reduce those possibilities depending on what the question is. All right, so this was quite a demanding question. And I'd like to know how many of you actually got 91. This is the answer. Oh, there are people who actually got 91. Okay. Now, I'm not saying that those people who put their hands up, I can see there are only 4 or 5, so they did very well. That's quite understandable. But sometimes you can look at the answers because the answers are there on the web page, right? If you fail, you can go and look at the answers and try to understand what it is. But the solutions there are very scant. So that is why we have these classes, because then we can. Okay, so the next problem is number 19, is it? Yeah. Number 19. Okay, thank you very much for that, for showing me your hands. Always raise your hands if you have solved the problem, then I have a good idea as to how you guys are doing. So the next problem is this problem, question 19. Let me share this, the new share on this. Okay, so there's your question. Question 19 says, f of n plus 1 is, there's a formula here. The formula says f of n plus 1 is equal to twice f of n plus 1 divided by 2. Okay, for every positive integer n. So the n's are positive integers and f is a function. So let's see, what are you talking about? The n is a positive integer, so you got f of 1, f of 2, f of 3, f of 4, and so on, because the n's are positive integers. So in other words, you've got a sequence, right? You've got a sequence here of numbers, because the n's are counting numbers. Now, what does this say? They say f of 1 is 2. So this first one here is 2. Now, what is f of 2? If you read this, you will see n plus 1 is the successor for n. It's a number immediately past n. So what we are saying here is that the value of a function at a particular point is equal to twice its previous values, the one just before that, add 1 to that and divide by 2. See? So there is a rule here. Like in this case here, To do this, you double the previous one, and that gives you 2 times 2, which is 4, plus 1, and divide by 2. Right? And that gives you 5 over 2. Okay, so f of 2 is 5 over 2. Now f of 3 is double that, the previous one, add 1 to it. If you double this, you get 5, add 1 to it, you get 6, divide the answer by 2, answer is 3. So we'll do the same thing here. Double this, add 1, 6 plus 1, 7 over 2. Double this, add 1. If you double this, you get 7, add 1, get 8. Double this, add 1, 9, divided by 2. So you've got a sequence like this. So you've got a sequence which is 2, 2.5, 3, 3.5, 4, 4.5. Okay, now this is a sequence that you can recognize. It's an arithmetic sequence because there's a common difference, see? So this is an arithmetic sequence. The question is find that one. So in other words, this will be the 101st term of the sequence. So your problem is to find the 101st term, and you know a formula for the nth term, for any term for an arithmetic sequence. If you know the first term, which we know to be a, and the common difference, it's an arithmetic sequence, the common difference is a half, as you can see, 2, 2.5, 3, 3.5, 4, 4.5. Okay, this is D, sorry, that's your common difference. And the formula for the nth term, this is school mathematics, is a plus n minus 1 d. And that you can work out straight away, that's 2. Okay, so therefore the 101st term will be 2 plus 101st term, so this is 100 times a half, because that's your common difference. That gives you 50 plus 2, which is 52. So your 101st term is 52. That's the answer to your question. There is something that I need to say here, because you guys are Olympiad students. There is a flaw in this argument. The flaw in this argument, is there anybody who wants to tell me what you think the flaw is? All right, so let me tell you. It's not obvious. The flaw is that I am saying this is an arithmetic sequence on the basis of just looking at the first few terms. I'll come to the conclusion that every term is obtained by adding a half to it. I don't know that. I only tried very few here. The fact that it's working here doesn't mean that it's going to work even at the millionth one. Do you understand? So that is where the flaw in the argument is. In mathematics, you can't afford to do that. You must, when you say something, you must be absolutely certain that what you are saying is true. So now how do you correct that? Okay, I will correct it on the next page. I'll go onto my whiteboard. And I'm now going to prove that this is an arithmetic sequence. I guessed it's an arithmetic sequence up to this point, right? So let me just clear these drawings. Okay, so how do I know that it's an arithmetic sequence? I only tried it for the first few. Let's go to the formula. The n plus 1th term is twice the nth term. Remember, now this is, you read this as the nth term. Add 1 to it and divide by 2, right? So from here, we can multiply by 2 on both sides. and then bring the, sorry, n plus 1, bring this 2fn to the left hand side and leave the 1 on this side, and then divide by 2 right throughout. You get half. And here we can say n equals 1, 2, 3, dot, dot, dot. You see, this is a very powerful statement here. We are saying you can take any term. If you subtract the previous term, you're going to get a half, which is the same as saying you're adding half to the nth term to get the next one. And this is not for small values of n like the way we tried. This is for everything. No specifications as far as this n is concerned. So this is very important in mathematics, especially if you're doing round 3, or even in the metric papers. If you're proving that something is an arithmetic sequence, don't just rely on the first few and say, well, it's going to work for everything. Mathematics doesn't work like that. Okay, so that's an important lesson for you guys. Okay, so let's get back to the next question. Okay, now we're going to question 20. So this is question 20. As I said, the problems are quite hard here. This question here is a question on probability. So let's have a look at this question. It says that Tom has 3 blue balls in a red in a bag and 4 red balls. Okay, so let's just try to. So he's got 4 red balls and he's got 3 blue balls. I can actually choose the colors here. I'm not going to do that all the time because it takes up too much of time. So this is what he's got inside his bag. Right. Now Dick takes out 2 balls from the bag and keeps them. Takes any 2 and he keeps them. Harry then takes out 1 of the balls left in the bag. So that means he's taken out 2 and there's some which remain. If the probability of Harry taking out a blue ball, Harry takes out a blue ball. So this is the problem about Tom, Dick, and Harry. Is x over 210, what is the value of x? Okay, now you do probabilities in grade 12, but I'm going to explain this problem anyway to you, and even the problem, though, even if you haven't done it, hopefully you will understand the logic behind it because it's a logical problem. Okay. Now just remember what probability is. Probability means the number of successes. Successes means, for instance, taking out a blue ball. That's called a success over the total, right? So if you know, for instance, if it's going to rain for 6 hours of the day, and I ask you what is the probability that it's going to rain, you will tell me, well, it's going to rain for 6 hours and there are 24 hours in the day. So therefore the probability that it will rain is 1:4. You know how to calculate it. You look at the number of successes and over the total, and that is how you work out the probability. So bearing that in mind, let's try to solve this problem. I'm going to go to my whiteboard. Just remember, he's got 3 blue and 4 white. He takes 2 out first. He keeps them. And then Harry takes 1 of the balls, 1 of those balls. And we want to know what is the probability that Harry will take out a blue ball. Okay, so let's just go to our whiteboard. And clean it. Right. Now, Dick takes out 2 balls from the pack. So he's got 7. I'm going to put down as 3 blue and 4 red. I'm not going to color them. That's what he had originally. He takes 2 out. Now, what are the possibilities as far as the colors are concerned? He could have taken out 2 blacks. He could have taken out 2 reds. He could have taken out a black and a red. You don't have to say red and a black. Both cases are the same, right? Okay, so in this case here, what is the probability that he takes out 2 blacks? There are 7 balls altogether. Right? He closes his eyes and he puts his hand inside and he takes out 2 specific balls. What is the probability that he takes out 2 blacks? Right. The way to do that is you work out the total number of ways in which you can take out 2 balls. There are 7 altogether, and you want to take out 2. Now last week, okay, I'm just going to digress a little bit here. I told you a fact that you must remember is the number of ways of choosing 2 objects from n objects is n into n minus 1 over 2. That's a very important fact. The number of ways of choosing 2 objects from n objects is n into n minus 1 over 2. Yesterday when I did it with the juniors, one clever junior asked me, okay, what about 3? He asked me, how many ways can you choose 3 objects from n objects? And I gave him the answer. And the answer is, if you had 3, then it's very similar to this. But what you do is the denominator, instead of putting 2, you put 1 times 2. And then for 3, it will be n times n minus 1 times n minus 2. You put 3 factors there. And at the bottom, you put 1 times 2 times 3. So that is the number of ways in which you can choose 3 objects from n objects. Right. So this is just a digression. If you want to know more about this, you go to the book and you read the chapter on counting. Very, very useful thing to do, all your brighter mathematics students. Because here I've got a whole thing, maybe 17 or 20 pages, I don't know, on how to count. There are various ways of counting. So if you read through the whole thing, you learn quite a lot about how to count. And amongst them, you will read this thing here. So the number of ways of choosing 2 balls from 7 balls is 7 times 6 divided by 2. So that's 21. Right? That's the total number of ways in which you can choose balls. The number of successes, now watch. The 2 balls can be chosen from 3 balls. So if you name them, ball 1, ball 2, ball 2, you can choose ball 1 and ball 2, or ball 1 and ball 3, or ball 2 and ball 3. There are 3 ways in which you can choose 2 balls. So those are the number of successes. Because you could choose any 2 of those 3 balls, right? So there are 3 ways in which you can do that. So the number of ways of choosing 2 black balls of blue balls is 3 over 21, which is 1 over 7. And likewise, if you look at that, again, your denominator is 21 because you're choosing 2 balls from 7. But those 2 balls can be chosen from any of 4 balls. See? So you got four red ones, and you're going to pick 2 of that. And how many ways can you pick 2 red ones from 4 red ones? That's the answer. It's 4 times 3 divided by 2, which we have seen even last week. See? So the number of ways of choosing 2 red balls from 4 red balls is 6 over 21. Okay, so that takes care of that. And then here, you're going to pick 1 ball from 3 and another 1 ball from 4. The blue ball can be chosen in 3 ways, and the red ball can be chosen in 4 ways. So altogether, to choose the black and the red there are 12 ways of doing it. Okay, you can understand this if you name the blue ones as B1, B2, B3, and the red one as R1, R2, R3, R4. You can see how many BRs have you got. With B1 you got 4, with B2 you got 4, with B3 you got 4. So that is why it's 3 times 4 here. And you can see this must be correct because when you add up all these things, you got all the possibilities. 3 plus 9 is 9 plus 12 is 21 over 21. So here we've exhausted all the possibilities. So the probability of finding any one of these is that. All right, now this is at the first stage. This is the number of ways of choosing 2 black balls. Now I just want to go on with this thing here. This problem is a hard problem. I told you that I don't know why these people gave such a difficult paper. Anyway, I have to admit that I had to spend quite a long time trying to solve all these problems. I don't look at other people's problems. I always try my own. If I fail, I try again until I get it. So now, this is the first stage, right? Now, the second stage, what happens? Harry picks 1 ball from the remaining lot. Now, let's try the first case. Right? What remains? You had 3 blue and 4 red. So if we took 2 B, there's 1 B left, and there will be 4 reds. This is for the BB. This is what he keeps them. So when Harry goes into puts his hand into this thing, he's only got 5 balls there because the 2 balls have been taken out. The same thing if you had 2 reds here. If Tom had taken out 2 reds, then the 3 blue would have still remained, and the 2 R's would have. So the 5 balls there will be 3 blues and 2 R's. And likewise, if you took out an R and a B, then you'll have 1 B taken out, so you got 2 B's, and 1 R has been taken out, so you have 3 R's. So in each case, in this case here, you got this is what remains. Here, this is what remains, and here, this is what remains. Right. Now, for each of these cases here, there are 3 cases out of 21, 3 cases out of 21, in which case you have BB. And for each of those, what is the probability there's a blue ball is taken? Remember, Harry is going to take out a blue ball. So to take out a blue ball from 5, There's only one way you can take it out. That one blue ball, there's 1/5. The probability of success here is 1. You can only take out that particular one from 5. The total number of ways you can take out one ball is 5. So this one is straightforward. Now here he's taking out one blue ball from 3. Three blue balls, and there are 5 altogether. So the probability of taking out a blue ball is 3/5. You've got a much better chance of taking a blue ball in this case because there are 3 here. And likewise, the probability of taking out 2 balls from these 5, 2 blue, is 2/5. Now here, this is where the thing comes in. The first round, there are only 3 possibilities, and the probability of taking out a blue ball after that is done is 1/5. So the probability in this case of taking out a blue ball is, you have to multiply these because there are only 3 cases where this thing happens, and in those 3 cases only 1 of 5 occurs, right? So you have to multiply this and you get 3/105, right? You get the probability that in this case here, Harry picks out a blue ball. In this case here, we've got 3/5 here. That was the second case. And the probability here is 18/105. Right? And here in the last case, you got 2/5. So in this case here, it's 24/105. So the question is now, what is the probability that he picks up a blue ball? So in this case, it is that. In the second case, it's that. So you add these 2 probabilities. In this case, it's that. So you add up all the number of ways in which you have a success, right? Towards the end, he's picking up a blue ball. You may add them, and you will get 3 plus 18 is 21, plus 24 is 45. So there is a probability that he picks up the blue. That's the answer to the question. But they said it's 2/210, if you recall. It's x over 210. So you can say 210 is twice 205. So x must be 90. Okay, so that's quite a mouthful, guys. And even in the grade 12 paper, it's very unlikely that you'll get a question like this. It's quite a complicated question, but I hope, even if you didn't understand most of it, I hope you got an idea as to how you calculate probabilities, right? You have to do it step by step. I just want to check to see whether my answer is correct. Usually my answers are incorrect. If it's incorrect, I'm not going to go over it. I'll tell you to go and check it out to see where I made the mistake. X equals 90, right at the bottom. Bingo. I don't have to do this again. Now, I'll be very surprised, unless you're in grade 12 and you're a pretty good student, you should be able to get x equals 90. So how many of you got x is 90? Oh, that's very good. At least there are 2 people. Wow. Okay. Okay, as long as you're true to yourself, that's fine. It means you are very good to solve this problem because it's not easy to solve it. But I'm sure if you do sufficiently many problems, you'll be able to get it. Okay, let's now get on to the next one. I'll just stop sharing and go to my whiteboard. I mean to my PowerPoint presentation. So there we have it. Okay, so the next problem looks like this. Question 22. Okay, if x is this, calculate the value of x squared minus 12x plus 40. Without a calculator, right? I'm sure many people see this as, what the heck? Without a calculator, I don't know what square root of 2 is. And anyway, I can just approximate it. And then when I do that, I've got a square root sign. Yeah, I don't know how to find the square root of another complicated looking thing. And then I have to square that and do all this. So it looks as if it's a very complicated problem. Without a calculator, how do you do this? All right, so I'm going to show you how you can do this. There are two ways in which you can solve this problem. I've given both of them in the solutions. The one way is a little bit unfair. I'm finding the square root of 38 minus 12 root 2. I'm finding the square root of that. And I'm going to assume that it also looks something like this. In other words, it's some number plus something times square root of 2. In fact, it is true. Whenever you have a thing like this, the square root of that also looks very similar to that. Something times square root of 2. Okay. So I'm going to assume that the square root of this looks like that. Yes, Nekwamba? Okay, Nekwamba, can you please put your mic off because we can hear you? Okay, so let me just put a brighter color here. This blue might not be very clear. Go back to black. Okay, the square root of this is equal to this. It means that if you square both sides, they must be equal. But when I square this, I got x squared. If you square that, you got 2y squared. And that's a nice whole number. But there's a middle term, which is 2xy times square root of 2. This times this multiplied by 2. That's the middle term. So now if you compare these two things, you will see 38 minus 12 root 2 is equal to this. So I can say that this part is 38 and this part is minus 12. So I've got x squared plus 2y squared is 38. This equals 38. And 2xy is equal to negative 12. Okay. Now this is an example of where it's hard to solve this problem because you got equations which are very unfamiliar and so on. So this is a good example of where you can actually try. Well, by the way, this means that xy is equal to negative 6. So we're going to assume that x and y are integers here. The square root of this is an integer plus another integer times root 2. So you got the product of two integers is negative 6. Let's analyze this. I'm not going to solve this thing, but I'm going to just try to hazard a guess. The product of two integers is negative 6. And when I put these in here, I got 38. So if you look carefully, you see if y is negative 1, this could be 2 and this could be 36. right? If we want this to be a perfect square, if this is 36, then x is 6 by inspection. You call this inspection, which is not a very solid way of doing it, to find at least one solution. So x is, if you try x equals 6, right? You get 36 here, and y equals 1, you got 38. So you see that xy could be 6, 1. X is 6, y is 1. Oh, but that's not true, because you've got the product of x and y is negative 6. Okay? But you can still correct it if you put 6 times negative 1. Or for that matter, even negative 6 plus 1. You could have had that as well. Okay? The product will be negative 6. And if you square this and add 2y squared, you will get 38. So we've got two possibilities. Your x plus y root 2, that's what we are trying to calculate, is if x is 6 minus root 2, because y is, I'm using this, 6 and negative 1, or if I use negative 6 and 1, we'll have negative 6 plus 1 root 2, plus 1 times the root 2. Okay, so these are two possible answers. But you can see that this is negative here, because negative 6 and this is root 2, which is 1 point something. And we got a square root here, so there's no negative sign here. So when you're taking the square root like this, you're always taking the positive square root. So this number here is a positive number. So it can't be this, because this number is a negative number. So this is what this thing is. So the square root of 38 minus 12 root 2 is actually equal to 6 minus root 2. All right, now once you got that, right, so just remember it's 6 minus root 2. And let me go to my whiteboard. Remember, the square root that we're looking for is 6 minus root 2. Oh, actually, in the problem, they said x was this. So I shouldn't have used x plus iy. That wouldn't have been the right thing to do. The x was something else. I think it was this. X is this. And the question was, what is x squared minus 12x plus 40? Anyway, I found this to be 6 minus root 2. So now we can do this. So what is x squared? It's 36. The middle term is minus 12 root 2. Square that, it's plus 2. That's x squared. Minus 12 times x. So it's minus 12 times this. Minus 12 times 6. And minus 12 times negative root 2 is plus 12 root 2. You're adding 40 to it. And happily, the root 2's disappear. So you have 36 plus 2 is 38. Make it 38 plus 40 is 78. 78 minus 72 is 6. So the answer is a happy 6. That x squared minus 12x plus 40 is actually exactly equal to 6. If you use a calculator, you will get some kind of a decimal, which is like 5.998 or something. But this is exactly equal to 6. When you don't use a calculator, you get the exact answer. All right. So that is one way of doing it. But there's another way of also doing this thing. a second way of doing it, which is also interesting. Let me go to the original. So this was the question, and see, I got one solution here. Okay, so there's another solution which I'm going to read out from here. Okay, so I can save some time. So you let x be equal to, or maybe I shouldn't do that. I don't like looking at solutions, rather work it out. So let's just go to my whiteboard again. So what we do is we let x be equal to, now this is a trick that is often used. I'm going to tell you what the trick is. You got 38 minus 12 root 2. This is what we need to calculate. Very often when you got objects like this, a useful object that comes in to play will be where you just change the signs. Look, if I had a plus b root 7, for instance, right? That's not a nice thing to work with. But if you create a minus b times root 7, if you create this, and if you multiply these two, you get a difference of 2 squares. So you get a squared minus that squared. Now the square root of 2, the square root of 7, when you square it, you get a nice answer, it's 7. So there's no square root here, you see. So one of the tricks of destroying a square root is by creating these and multiplying them. So this is what we will do. We'll create plus 12 root 2 and multiply them. So when you multiply two square roots, you're going to get a square root outside. It is a square root of the stuff inside. Multiplied by the square root of the stuff inside here. Now, in case you are lost, you have done this many times. Square root of 3 times square root of 5, without even thinking, you'll say square root of 15. What you do is you put one square root and you multiply the stuff inside. That's what I got here. I got one square root. You can see this big thing here, and I'm multiplying the stuff inside. Now, you see inside now, we are multiplying a minus b into a plus b. So that's exactly where I wanted to come to by creating this thing. And now here you get 38 squared minus 12 squared times 2. Right? I don't want to use a calculator, so you got minus 12 squared times 2, you're squaring that. So if you don't use a calculator, then you can take out 2 squared. The square root of 2 squared is 2. If you take out 2 squared from here, you have 19 squared. And if you take out 2 squared from here, this is 144. If you take out 4 from that, it's 36 times 2 is 72. Right? You're taking out 4, dividing by 4 right throughout. 19 squared is 361. 361 minus 72 is 289. And square root of 289, hopefully you know that is 17. I know Saurav knows it. It's 17, and 17 times 2 is 34. So the product of x and y is 34. All right. Now, We can actually calculate x plus y also. Let me just erase this part here to create some space. There's x is this, x plus y, right? I can find x plus y if I square both sides. Now watch. If I square both sides, let me just draw a line here. Sorry, I'm taking too long over this. X plus y, when I square it, what happens? I'm going to calculate x plus y. Well, the usual rule is this x squared plus 2xy plus y squared. Now x squared is 38 minus 12 root 2. Right? If I square this, the square outside square root disappears. So you have 38 minus 12 root 2. That is x squared. We calculated xy. Xy was 34. So 2xy is 68. We've just calculated that. Plus y squared, there's y here. When I square y squared, I'll get 38 plus 12 root 2. See? And happily, the minus 12 root 2 plus 12 root cancels. And you have 38 plus 68 plus 38. So you get 76 plus 68, which is 144. Ah, that's a nice number because we've got a square of this is 144. So lo and behold, x plus y is 12. Amazing. You got this horrible looking thing here. Right? When you add them up, you get 12. You got a square root, multiply that by 2, subtract another square root, and but when you multiply this, you get 12. So it's a very useful gadget here. When you put 38 plus 12 root 2. So a lot of nice things happen. So it could be minus 12, but x is positive, as you can see. It's a square root. The square root of 25 is always 5. It's not plus or minus 5. Huh? Bear that in mind. If you want to put plus or minus, you'll have to put plus or minus in front. But if you don't, you'll just take the positive value. It's an important fact. So you know the sum of these two numbers is 12, and you know this product is 34. Right? So how do we actually get the we need to work out x squared minus 12x or something. So let's do this. We've got 34 is equal to xy. Watch. We've got 34 is equal to xy, but I can replace y, right? Y is equal to 12 minus x. So I can make, there it is, I can replace the x, y, and I now only have only x's in it. So this y here, which we brought in by crook, right? We've got rid of it now, right? And we got the x's, right? Which was, our problem is all about the x's. And when you solve this, you get 12x minus x squared. And there you see suddenly you got this 12x minus x squared. If you bring the x squared to this side, minus 12x, if you bring it to this side, plus 34 is equal to 0. And if you recall, the problem was, what is x squared minus 12x plus 40? To do that, all you have to do is to add 6 to both sides, you see? And the answer is 6. Earlier on, we got the answer 6 as well. So guys, you can see, this is, you're not playing with this stuff, eh? You're not playing. I've given you 2 ways of solving this rather complicated problem. And so we are looking at quite advanced problems here. This problem I would have thought it would be in round 3, but somebody went overboard and they put this in round 2. Although it's a question right towards the end, but it's a quite a difficult problem. But I think if you've seen one, then you can tackle other ones. So that is a nice thing about these classes. You have an idea as to how to go around doing these problems if you're confronted with one of these. So all problem solving is all about is what is the strategy in solving a problem, right? Yeah, in this problem, yeah, the strategy is not clear at all, right? But when you have seen, I've given you two different ways of solving this thing, and that should help you to get started with whenever you have problems of this type. Okay, so let me just get back to my PowerPoint, and so this is what I got here. You see this thing which I've worked out in detail. So I got the alternative solution, and now you come to question 23. Right? This is another complicated problem. How many triangles with positive areas in the XY plane and vertices with integer coordinates are there satisfying this? Right? That is why I ask you to go over these things beforehand so you can understand the question. That itself is usually quite difficult to understand. So what we have here is, let's just unpack this for the time being. I'm going to sketch this region in the plane because you've got in the XY plane. So let's just draw the x-axis and the y-axis. They say positive areas, so let's just get into just the first quadrant. X lies between 1 and 4, so x is here, and x is 1. So x is somewhere here. X lies between 1 and 4. And likewise, y lies between 1 and 4, but that's in the y coordinate. So y is here. So you want both of them to be satisfied. So the way to do that is to look at the region that this thing specifies. So you draw your vertical line at 1 to get all the numbers whose x coordinates lie between 1 and 4. You'll have this long thing here. All the numbers here, right? Don't worry about the y coordinates, but the x coordinates will be between 1 and 4. And in a similar way, here, all the numbers in this strip here have got y coordinates lying between 1 and 4. But you want both of them to be satisfied. So you are looking at all the points in this. Yeah, it looks like a square. It's a square, 3 by 3 square, 3 by 3. But the question is integer coordinates. Right? It is told that the coordinates are integers. So we don't have to look at all these points. We look at only those which are integers. So therefore, let's look at all the integer coordinates. You draw the line across at 2 and 3. Let's just remain here as 2 and 3. And at x equals 2, x equals 1, we finished. X equals, oh no, you don't have so many. It's 1, 2, 3, 4. Sorry, let me just I drew the wrong diagram. So you got, I'm going to just draw that square, and I'm going to put down the numbers 2 and 3, which I should have done. 2 is here, 3 is here, and likewise 2 and 3. So we draw only 2 lines across the 2, 1, 2, and 3. 4 is already there, and you put the 1 here, the 2 at least, the 3. So we are looking at those points with integer coordinates. So it's just those points there. Those are the ones with, you're allowed to equal the boundary here. You can see equals 1, equals 4 is allowed in both cases, and they're integer coordinates. And if you look at this now, finally, you have that there are 4 points on each of those rows, and so you have 16 points altogether. Right. Now, how many triangles with positive areas in the xy plane and vertices this are there satisfying this? So how many triangles can you draw? See, that is the question. We can draw lots and lots of triangles, and because there are 16 points. Right? So I can take any 3 of these points and draw a triangle. But there are exceptions. I can't choose 3 along this line here. I can't choose 3 along this line or that line. So you can't choose any 3 in the same straight line. So one must be careful. So why don't we just say, okay, suppose we ignore the exceptions and we say, how many ways can you choose 3 points from 16 points? Now there's your, this thing comes back to haunt us now. I want to choose 3 points because I'm going to draw a triangle. I got 16 points. And earlier on, I actually gave you the answer, right? I told you if you got n points, the number of ways of choosing 3 points from n points is n times n minus 1 times n minus 2 divided by 1 times 2 times 3. If you recall, this is what I said. If you want to choose 4 points, then you put n into n minus 1 into n minus 2 into n minus 3, and at the bottom you add 1 times 2 times 3 times 4. You see? That is the number of ways of choosing 4 points. Right? So you go at the bottom, you only go up to your number 4. Here in this case you go up to 3, and at the top you only have 3 factors starting from 1 going backwards, and here you got 1 going forwards. So that is the trick. So you got n is 16 here because there are 16 points. So it's 16 times 15 times 14 divided by 1 times 2 times 3. I don't, as I told you, I don't multiply. 3 goes into 15 5 times. 2 goes into 16 8 times. So it's 8 times 5, which is 40. And 40 times 14 is 4 times 14. That's 56. So if I choose 3 points, any 3 points from here, there are 560 ways of choosing 3 points from 16 points. Now, the problem now is you have to take away from these those which are not allowed to choose. I'm not allowed to choose 3 points from which all lie in a straight line. I'm not allowed to do that. Okay. It means I'm not allowed to choose 3 points from here. So how many cases are there which you have to reduce from here? To choose 3 points from here, all it means is that you ignore 1 point. So the number of ways of choosing 3 points from 4 is 4 ways. Because you can ignore this, and you get 1, ignore this, you get another 1, ignore that, you get another 1, ignore that, you get another 1. So there are 4 ways of choosing 3 points from here. But now you got these 4, that line, you can do the same thing here. It's another 4 here, another 4, another 4. In each line there, you got 4 which you have to take away. So you have to remove from this 560, you have to remove 4 plus 4 plus 4 plus 4. But also there are the vertical ones here. How many have you got there? 1, 2, 3, 4. So the 4 verticals and 4 horizontals. Okay, so that's 16. No, I'm sorry, 8. 4 verticals. So the eight straight lines, and for each of the straight lines, right, I have 4 removed. So you have to subtract 32 from here. 8 times 4. I'll repeat how we get 32. You're not allowed to pick 3 from here. So 4 of them have to be eliminated. But now, to quickly go through that, the 4 points lie on a straight line in how many cases? 1, 2, 3, 4, 5, 6, 7, 8. But wait, you can also have these in the diagonal here, you see. These also lie in a 4 points lying in a straight line here. And here too, you can have the other diagonal. So there are actually 10 cases where you've got 4 points lying in the same straight line. So I'm really supposed to subtract 10 times 4 and not 8 times 4. Okay, so I'm not supposed to subtract 32. I'm supposed to be subtracting 40 because there are 10 cases where you've got 4 points lying on the same straight line. Okay, so you might think that we are finished here, but unfortunately not quite, because there are still some other cases here. Look at this. There are 3 points here as well. You got these 3 points. You see, they lie in a straight line. So you must take that one out as well. There's one there. And another one here. There's another one here. And another one here. So there are 4 more cases where you've got 3 points lying in a straight line. So you have to remove those 4 as well. Right? So altogether you got 520 minus 4, so 516, and there are no more cases. Right? Those are the only cases where you got 3 points, 3 or more points lying on the same straight line. The answer is 516. And once again, it's not an easy problem at all. I got it wrong when I did it because I missed out quite a few of these lines here. Okay, so as promised, I will share the solution with you. You will get this whole thing. So if you go down the page, sorry, sometimes to just manipulate on this thing here, it takes a bit of time. But I'm trying to, okay. Yeah, you see, in this picture here, it's quite clear what the 10 lines are. See, the 4 horizontal lines, the 2 diagonals, that makes 10, and these 4 blue lines. So these lines, they say which one you have to remove, and you'll see at the end, the answer is 516. So if you didn't understand it, you still got a chance to do it. And in any case, this recording will be sent to you, so you can go back and listen to what I said and go on. So we're still problem number 24 of last year's. We've still got 2 more to go. And I will be the first to admit that these problems were very difficult. This next one also is quite quite a difficult problem. So next problem says the following. A circle C has got radius 5 and its center is at negative 3, 2. Right? And the question is, okay, a point A has got coordinates A and 2. So it means that the y coordinate for A is 2, but we don't know what the x coordinate is. Q is the midpoint of AB and traces out a circle as B moves around the circumference of the circle C. For what value of A will the center of the smaller circle formed by Q lie on the circumference of circle C? Another very difficult problem, I thought. Okay, so let's do it. You have a choice. You can skip it and go on. I don't. I have to tell you how to do it. So I have to struggle and work it out. Okay, let me just go to my whiteboard. Or maybe no, I'll go to my whiteboard. And then I will tell you what the question is. My mind is getting very dull now, so I can't remember what I'm supposed to be doing now. What am I doing? I'm going into new share, and I'm going to go to whiteboard, and I'm going to share this whiteboard with you. Need to clear up all these drawings, right? And now let me do the drawing of this thing here. You got a circle of radius 5, it's got its center at -2. So let me draw the x-axis and the y-axis here. So you got a, because it's a coordinate problem. Oh, the circle is at center, -3, 2. So let's just put this on this side. So the center of the circle is at -3, 2. So this is, so the center is here somewhere. So let's draw a circle. Oh. Okay, drawing the circle here is usually an ordeal because it doesn't allow you to draw the circle very well. You can see the center is off beat a little bit. I can move it. So it's going to be -3, 2. Okay, so if I approximate the center there somewhere, the center is at -3, 2. Right. I'm looking at the question, and so I can you can't see it. The next thing that is said here is that point A has coordinates A2. So point A, its coordinates are A and 2. So the y coordinate for A is the same as the y coordinate for this, and it's got the x coordinate is A. It's not specified what A is. So we'll just choose A to be somewhere here. Let me, both of them are on the same horizontal line. So let me draw the horizontal line. So the A is somewhere on this line here. Okay. And its coordinates are A and 2. So let me just put, it's called capital A. Okay. Then it says that Q is the midpoint of AB. There's A. Where is B? There's no B here. Okay. But it says as B moves around the circumference. So B, as it moves around the circumference, B can be any point in the circumference. Then what happens is that you choose a point B on the circumference, and you join the line AB, right? We call this point B, and Q is the midpoint. So Q is right in the middle of this. So these are equal. BQ is equal to QA. But now they say the B traces goes around the circle here. So you could have another point B here, for instance. Let's call it B prime. And for that point now, you got a new center. Again, you join this thing. You join A to that point. And you find the center. The center of this is somewhere. Let's call this Q prime. Q and Q prime, the Q's are the centers, and the B's, I've got B prime, are points on the circle. So you got, these are equal, like that. Okay. Now, here we got this diagram, and then it says, for what value of A, the question mark is here, for what value of A would the center of the smaller circle formed by Q? So it seems that Q and Q prime also, they lie on a circle. We don't know, that's not obvious at all. Because as you move B around, you got Q, is from here, Q will be going up there somewhere, and then you join this and Q will be here somewhere, and so on and so forth. But it's not quite clear that Q also lies inside a circle. But they say that the center of the smaller circle formed by Q lies on the circumference, it lies on the circumference of circle C. Right. Now, this is a hard problem, guys. Okay. The way to do this, after a lot of thought, is to take the center of this line here. I'll tell you why I'm going to take the center of that line. We'll call it R. The center of the line from A to the center of the circle. Let's call this O. Right? Now this is not one of the Q's because we didn't join A to a point on the circumference. We join A to the center of the circle. So I'm using another symbol here. It's not one of the Q's. It's not one of the, right. Why did I do that? The reason why I did this to find, because I got midpoints, you see. I got two midpoints. I got a midpoint here, I got a midpoint here. So let's take the midpoint here. So I choose R to be the midpoint. And then I try to observe something. What I observe here is by the midpoint theorem, the line joining the midpoint of two sides of a triangle, see, I've got a midpoint here, I've got a midpoint here. So let's just join these, okay? And if I join these, it's going to be parallel. So R should have been here somewhere. The line joining midpoint. So QR is actually parallel to that one. And likewise, I chose B prime to be almost like a straight line here, unfortunately. Okay, these are, let's just take that out. It's not too much of a hassle to take this line out here. I'm going to choose B prime at a different point. Let's do this all over again. I'm going to choose B to be another point on the circumference. Right? Let me choose it here somewhere. And then I'm going to join it to A. And I'm going to take the midpoint of that. And we're going to call that Q. So this B prime is another point. And here you got, this is Q prime, like this. So I'm going to say R is the midpoint of AO, Q prime is the midpoint of this, like that. So by the midpoint theorem again, I got QR is going to be parallel to that. So this QR is going to be parallel to this line. And this line here is parallel to this. This is by the midpoint theorem. But more importantly, QR is equal to half of this. And it's given there that the radius of the circle is 5. It was given that right in the beginning. So QR is half of that. And Q prime R is half of that, which is still 5. So it means that Q R and Q prime R are both equal, and they're both equal to 2,5, 2.5. Right. Now, so far, you had no idea why I am doing all these things, right? What I'm doing here is that I've actually proved that if I take this fixed point, which is the midpoint of this, no matter what Q is, its distance from this point here, R, is always going to be 2.5. See? Which proves that claim that these people made that Q and Q prime lie on a circle, because its distance from R will always be 2.5. Right? So the question was, and this is the center is going to be R. The center of that circle, right, which Q lies on, is R. So I've just proved that R is the center of the circle, which Q lies on. What is R? R is along AO. Right. I'll go back to my question. Right. For what value of A will the center of the smaller circle, we call it R just now, formed by Q, that's what we did. For what value will that R lie on the circumference of circle C, right? The circle that we have. For what value of R? So let's just go back to our whiteboard, right? So we want R now to lie here. So that means that we want R to lie there. That means A is somewhere here, because R was the midpoint, you see. So A is going to be here. I'm sorry, the diagram is a little bit, the A would have been here, and the R, you want it to be on the circle. So this length here will be the same as the radius. So the distance from A to R will be 5. Right? Because R is the midpoint of AO. So the distance from A to R will be 5. So what is little a? Little a is this length here. That's your little a. Right? And the question is now, what is that? Okay, now this is a little bit of, I'm going to leave the rest to you, because now you can see what is going to be. Redraw this thing and put the R here. This is quite messy. But in the end, you will have that A is actually 7. Okay? Because you got -3 here, you see. So when you put -3 and you add 5 to this, then you're going to get 2 on this side, right? And 2 plus 5 is 7. Okay, you can think about that. But it's a very hard problem. Extremely unfair. I would not take any blame for that problem. And finally, at question, if we go back to my original thing, and it's the last question, we don't have any time to go outside question 2020. That is why I kept saying if we have time, because this is a very difficult paper. So question 25 says the following. This is not going to take too long. On level ground, a car travels at 63 kilometers per hour. Going uphill, it slows down to 56 kilometers per hour. That's understandable. And going downhill, it speeds up to 72 kilometers per hour. Sounds very much like my old VW that I had many years ago. The maximum speed it could travel was 56 kilometers per hour. Okay, so here I'm going to just trace the path of this car. So there's a car which is traveling on level ground, right? When it comes up to a hill, it slows down to 56 k's. But when it goes down the hill, it speeds up to 72, downhill, 72, right? And it goes on to a point B. Okay, but suppose now put all the level ground here, and let's ignore this last part, and we put all the higher ground here and all the lower, the uphill and the downhill. In a diagram, we will just make it look like this to simplify it. So the car is traveling that distance along the level ground, that distance up a hill, and that distance down the hill. And then the return trip goes that distance up the hill, that distance down the hill, and that distance that way. So you got 3 different distances here, right? So let's just give names to these distances because we need to calculate. We got times involved here. It takes 4 hours and 40 minutes, and we know the speeds. So let's get the distances in place. So the distance from let's call this distance here A. Flat ground, uphill B, downhill C. So when it's traveling on flat ground, it travels for a distance for 8 kilometers all along flat ground. Okay, so it travels at 63 kilometers per hour, which means that the time that it takes to travel on flat ground is A, the distance over speed. That's the time that it takes in hours. Right. Now, likewise, when it's traveling uphill, it travels at 56 kilometers per hour. So the time that it takes to travel uphill is B over 56. This is the distance it travels over its speed uphill, and the time that it takes to travel downhill is C over 72. Right. Now that is the trip on the upward journey. And it takes 4 hours to travel that. So in other words, when I add A plus B over 56 plus C over 72, the total number of hours is 4. But when it goes backwards now, when it travels from B to A, it takes 4 hours, 40 minutes. Now, what is the reason for that? When it's going back this way, whereas downhill was taking 72 here, but now this becomes uphill, you see. So when it's going on the return journey, it will have to travel 56 kilometers per hour uphill. So the time that it takes to travel uphill will be C over 56, and it'll be B downhill, B over 72, and the same Oh, I'm supposed to put A over 63 here. And here it's also A over 63. On the flat, it will take the same time. And now this is actually 4 hours and 40 minutes. So it's 4 2/3. The question is now, what is the distance between A and B? So the problem is, what is A? Oh, this is B here, by the way. This is the end part. And it says from A to B, and I'm just calling this to be B. So we are looking for A plus B plus C. We've got two equations, and we have to add A plus B plus C. Now that looks very complicated. But what's now? To get A plus B plus C, I got the different denominators here. I got 63, 56, and 72. Why not add these two and see what happens? And then I'll get my A plus B plus C. You'll get 2A over 63, that plus that. Here, B is a common factor. One over 56 plus 1 over 72. Right? And when I add these, see, I get now 1 over 72 plus 1 over 56. And when you add these, you get 8 2/3. Right? Now, interestingly, when you add these two, I'm not going to do it, you actually get 1 over 63. Right? No, I'm sorry, you get 2 over 63. We'll do it. It's 56 times 72. You can find the LCM if you take a try, but I would just put 56 times 72 at the bottom. Let's take the product, and the numerator will be 72 plus 56. That gives you 128 over 56 times 72. And now I will cancel, take off like terms. 72 plus 56. 8 goes into this 9 times. 8 goes into the 16 times. And 8 goes into the 7 times. And 8 goes 2 times. So you get 2 over 63. So this quantity here is 2 over 63. Right? So, sorry, I'm going to go take this entire line and I'm going to move it, squeeze it in here. So you get 2A over 63. This part here is 2 over 63. So you got 2B over 63. And this part here is still 2 over 63. It's the same thing. So you have 2C over 63. And that is 8 2/3, which is 26 over 3. Right, to get A plus B plus C, all I have to do is to multiply both sides by 63 over 2. Right? So if I multiply this by 63 over 2, I have A plus B plus C. So the answer is 26 over 3. Take this and multiply the whole thing by 63 over 2. Right? And that is A plus B plus C. You can just cancel. 2 goes into 16, 13 times. 3 goes into this 21 times. And 21 times 13 is 273. Sorry for this mess, but that is in principle. Again now, when you get these equations, you have to figure out how do you get A plus B plus C. But you can see you've got 1 over 56, 1 over 72, 1 over 72, 1 over 56 here. So when you add them, you're going to get the same coefficient. So you'd have to try adding 1 over 56 and 1 over 72, and it comes as a pleasant surprise to see that you got 2A. All right, so that takes care of number 25, and that's the last one. I've gone 10 minutes beyond the time, and I thank you guys for staying on till the end. Those of you who had the courage and the determination to go through this entire thing. I'm sorry, I'm not going to make any apologies. Those people who set the paper must make an apology, because it took me almost 2 hours to just work out a small number of questions, 8 or 9 questions. Okay, so the next time we meet, we go into 2019, and we'll do the whole as many possibles from 2019 as possible. Hopefully, 2019 is not going to be as difficult as. Oh, you know what happened here? Now I understand. Let me explain to you why these things were so difficult. You know who you must blame? Why is the problem so difficult? You blame something, you blame an invisible man. Actually, an invisible creature called a virus. A tiny little creature nobody can see, which has brought the entire world to its knees. All the scientists and all the presidents and everybody else, this tiny little thing, all proves that God is in control. Caused havoc here. Now, what has this got to do with this problem? It's because they didn't write round 2 last year because of the virus, and this was also the 3rd round. Right? So this is the first round, second round, and the 3rd round, I think, if I'm not mistaken. And or maybe I'm mistaken. Oh no, yeah, whatever it is. But I think this was also the 3rd round, so that is why they made it so difficult. I'm trying to justify these people who set this difficult paper. Okay, so next week we will do 2019. I now leave the floor open. We've got 54 people who have remained behind, and perhaps you've got something to ask me. So let me just stop sharing. And guys, I didn't give you any time to think in this thing, but I see all my the Matthew, Dean, Faiz, all these are well-known people. Michael, I think that's Michael East. So guys, are there any questions here? You got any comments? In the chat group, somebody asked Tato to put his mic off. So please, Tato, just remember that. Okay, somebody asked me a question. Let me just go to that. Now watch. Interesting question. Fractions usually can be quite a pain. So the question this person asked was the following. The person said, look, you got 3a, 3b is equal to 4a. So the person said, therefore, a is equal to 3 and b equals 4. And a plus b must be 7. Unfortunately, that's not true. You see, from here, you can write down a over b. If you want to work out a over b, that's a fraction. 3b is equal to 4a. So the 3 goes, when you cross multiply, 3b is equal to 4a. That's what happens. I'm sorry. 4a. So a over b is 3 over 4. And she said, therefore, a plus b is 7. What's wrong with this? Could have been 6 over 8, could have been 9 over 12. A fraction is not uniquely written. And that's the thing about these problems. If it's simplified completely, then it's 3 over 4 and the answer is 7. But it's not simplified completely. A over b is not simplified. M over f or something was simplified in that problem, not a over b. So And as we saw, A was not 3. A actually was 75, remember, in that problem. So this would have been a mistake, right? I hope that answers the question that somebody raised. Then Thierry asked me, how do you get the formula for choosing 2 successors from n possibilities? We did this last week. The formula was n into n minus 1 over 2, but I can show it to you quickly. How do you get that formula? And here's the answer to that question. Let's just go back to my whiteboard. Clear it. Right. The question is, I want to choose 2 from n. 2 objects from n objects. Right? Okay, what I'm going to do is I'm going to call these objects 1, 2, 3, 4, all the way up to n. From choosing 2 objects, I can choose 2 and 4, or 3 and n, or 1 and 4, or 2 and 55, whatever it is, right? So let's do it like that. I'm going to choose 2 objects from here. The way to choose 2 objects is, first, let me insist I choose one of the objects to be 1. The second object can be chosen as 2 or 3 or 4 or all the way up to n. So that's n minus 1 choices for the second object. We can have 1, 2, 1, 3, 1, 4. But we're starting from 2 now, you see. All right, so this takes care of all the ways in which 1 appears. We finished with 1. Let's get on to 2. Let's find all the places where 2 occurs. We're not allowed to count 1 because we finished with it. But this time, 2 will have to be paired with those. And you're starting with 3 here now. So you got n here. So the number of pairs here are n minus 2. See? So you can have 2, 3, you can have 2, 4, and you can have 2, n. And if you find out how many are there altogether, you'll see you get n minus 2. And you keep going like this. And if you're looking at starting with 3, you'll have n minus 3. Until you come to this one with n minus 1 in it. And there you have just 1. So n minus 1 can be paired with only 1. So if you're counting the total number of ways in which 2 objects can be chosen from n objects, right? There are n minus 1 if 1 is there, and so on and so forth. The total number of ways is the sum of all these things here. That's the total number of ways of choosing 2 objects from n objects. But this is just the consecutive numbers. See, these are consecutive numbers. 1 plus 2 plus 3 all the way up to n minus 1. And you know that this one here, every person who does Olympiad knows the sum of the first n minus 1 numbers. It's n minus 1 times the next one divided by 2. And that's where the formula comes. Okay. Again, when you do counting, you'll see that I show you in the book this problem, that question is answered. Okay, let's just get back to. Okay, so I'm not sure who asked that question, but I hope you that satisfies you. Anybody else has got any questions? Okay, so if there's nobody else, let me wish all of you, hope you all have a nice, happy weekend. And we will send the solutions, the PowerPoint solutions to you. We'll mail it on the Google Classroom. I hope you know how to handle all those things. And also the recording for this. Oops, I should have stopped the recording somewhere along the line.